The next thing we're going to talk about is how to add and subtract two matrices. Okay, so let's read about it here. In the first bullet point, it says, in order to add or subtract two matrices, they must have the same dimensions. Okay, matrices of different dimensions cannot be added or subtracted. Okay, so they absolutely have to be the same size, or you cannot add or subtract them. Okay, for two matrices A and B of the same dimensions, okay, their sum A plus B is found by adding corresponding elements. Okay, their difference A minus B is found by subtracting corresponding elements. Okay, and then last thing to note, it is always true that if you add A plus B, it's going to be the same thing as B plus A, but it is not always true that A minus B is equal to B minus A. Okay, so remember, just think about two numbers. If you're just adding two numbers, and we're not even dealing with matrices here, okay? If I do 3 plus 4, that's 7. That's the same thing as 4 plus 3. The order doesn't matter when you're adding, okay? But with subtraction, the order matters. If I do 3 minus 4, that's -1. But if I do 4 minus 3, that's +1, okay? So it's the same thing with matrices, okay? If you add two matrices, as long as you can perform that operation, the order doesn't matter. But with subtraction, the order does matter, okay? So hopefully you realized from this little blurb up here that basically to add or subtract two matrices, they have to be the same size. And then all you have to do is, you're going to form a new matrix. It will be the same size as the two original ones, okay? And if you're adding, you're just going to add the numbers in the corresponding locations, okay? If you're subtracting, you're going to subtract the elements in the corresponding locations, okay? And you'll get a new matrix. Just pay attention to the order of subtraction if you are subtracting. All right, so let's practice. So in example 4, okay, you have some matrices, okay, and you're either adding or subtracting, okay. The directions say to perform the indicated operation if possible, okay. So, you may not be able to do the operation, and if so, you just state that. All right, so here are the matrices in example A. First thing you need to check is the size, okay? This is a 3 by 3 matrix. There are 3 rows and 3 columns, okay? The second matrix is also a 3 by 3. Because they are the same size, we are able to add them, okay? So we're going to get a brand new matrix when we add them, okay? The result will also be a 3 by 3, okay? All you do is you're going to add the elements in the corresponding locations. Okay, so like first row, first column, look at those numbers. 1 plus -1, that's going to be a 0. Okay, and then let's see, I'll use a different color here. Let's go across. So then the first row, second column, there's a 2 here and a 6 here. Okay, I'm going to add, here, I'll put them in colors. Put this back in pink. Okay, so then the first row, second column, okay, we've got 2 plus 6, okay, that's going to give us an 8. Okay, so hopefully you see how this is working. All right, and then we've got the first row, third column, okay, those corresponding elements, first row, third column, we've got -3 plus 8, that's going to be a +5, okay, so that is going to be your first row of your answer matrix, okay? All right, and then you just keep doing that, okay? So -4 plus +4 is going to be a 0 here, okay? 5 plus -2 is going to give us a +3, okay? 6 plus 7 is going to put a 13 in the second row, third column, okay? And then do the last row. 7 plus 9 is going to give us 16. -8 plus 5 is going to give us a -3. And then 9 plus -3 is +6. Okay, that's it. This is your answer. Okay, brand new matrix. It's going to have the same dimensions. Okay, you just add the corresponding elements. That's it. Okay. All right, let's look at example B. Okay, you're trying to add these two matrices. Okay, let's look at our dimensions. Okay, this guy has 3 rows and 1 column, so this is a 3 by 1 matrix. Okay, this guy has 1 row and 3 columns. Okay, they are not the same size. Okay, they have different dimensions. Okay, so you cannot add them. Okay, so we're going to say this is undefined. Okay, we cannot perform the addition. Okay, so I'll even write that up here. Okay, the matrices are not the same size, so cannot add. That's it. You move on to the next one. Okay. All right. In part C, let's do a subtraction problem. All right. So what we've got here, okay, we're trying to subtract this minus this. Okay. So again, check out your dimensions. They have to be the same size in order to subtract. Okay. So this guy has 3 rows and 2 columns. So this is a 3 by 2. Okay. This is 3 rows, 2 columns, also a 3 by 2. They're the same size. You can subtract them. Okay. So you're going to get a new matrix. It is also going to be a 3 by 2. Okay. All you need to do is subtract the corresponding elements. Okay. Be careful with your subtraction here. Okay. You can definitely just do this in your head. I'm just going to write it out for you. Pay attention to your signs. Okay. So this top, let's see, let's color code these a couple of times. Let's do the first row, first column. Okay. We're subtracting those numbers. So it's going to be 2 minus 8. Okay. And then if you did the first row, second column, it's going to be 5 minus 12. Okay. You've got to subtract the corresponding elements. Okay. Be very cognizant of whether or not you are subtracting a negative. Okay, because you can easily mess up your signs here. Okay, so let's move on to the second row, first column. Okay, this is going to be 0 minus 1. Okay, let's see, running out of colors here. Let's do the second row, second column. Okay, pay attention to this one. This one's going to be -4 minus a -7. So be careful there. Okay, again, you don't have to write this out. I'm just doing this to show you the first time. Okay, all right, back to purple and blue. That's all I got. All right, so third row, first column. We've got -1 minus 5. And then for that last position, I'll put it in green. The green kind of stands out. So 3 minus 2. Okay. All we did was subtract corresponding elements. Cannot emphasize enough. If you are subtracting a negative, you've got to be careful there. Okay. So let's go ahead and simplify this matrix, and that will be our answer. Okay. So 2 minus 8 is -6. 5 minus 12 is -7. Okay. 0 minus 1 is -1. -4 minus a -7. Remember, minus a minus becomes plus a positive. So this is going to be -4 plus 7. That's going to be +3. And then -1 minus 5 is -6. 3 minus 2 is 1. Okay. Here's your answer right here. Okay. All right. So hopefully addition and subtraction of matrices are very straightforward for you. Okay. Now we're going to start talking about multiplication. Okay. First thing I need to tell you is that there are 2 types of multiplication for matrices. Okay. There's an easy version of multiplication and there's a harder version of multiplication. Okay. We are going to start off with the easier version of multiplication. Okay. They're very different things. Okay. We'll do the easy one first, and then we'll get into the more difficult one. Okay. Scalar multiplication is the easiest type of matrix multiplication. Okay. This word scalar means just a number. That's it. That's what that means. Okay. So what scalar multiplication is, and we're going to read about it in just a second, you are multiplying a matrix by a number. Okay, so let me write that down. Okay, so here all this means is you are multiplying a matrix by a number. Okay, this is the easier version of multiplication where you just multiply a matrix by a number. Okay, in the more difficult version of matrix multiplication, you're actually multiplying two matrices together. Okay, and that's a little bit complicated, but not too bad as long as you know the rules. Okay, so first let's just look at the easier case of scalar multiplication where you are just multiplying a matrix by a number. Okay, so under here, let's read about it. It says the product of a scalar k, which is just a number, in a matrix A designated k times A is the matrix A with every element multiplied by k. In other words, scalar multiplication of a matrix simply means multiplying each element of the matrix by the same number. Okay, so that's all it is. If you have scalar multiplication, you're taking your matrix and you're multiplying every number inside the matrix by that number. That's it. Okay, so in example 5, we are given the matrix A and we want to find each of the following. Okay, look how it's going to be given to you. Okay, read it to yourself. This is just 3 times the matrix A. Okay, 3 times the matrix A. So that means you're going to go to your matrix A and you're going to multiply every single number inside by 3. Okay, and again, this is something you can do in your head. I'm just writing it out because you're seeing this for the first time. Okay, so I'm doing 3 times 2, and then 3 times -4, okay, and then 3 times -1, and then 3 times 3, okay. That's it. I took every single number inside the matrix and I multiplied it by 3. Okay, so my final answer is going to be the matrix 6, -12, -3, +9. Done. That's it. That's it. That's all scalar multiplication is. Okay. In part B, okay, we are still dealing with the original matrix A, okay, but now it says -A, okay, so remember, this is just the same thing as -1 times A, okay, that's what -A means. So you're just going to take every number inside and multiply it by -1. Okay, so this is going to be -1 times 2, -1 times -4, -1 times -1, -1 times 3. Okay, so simplify. This is going to give us a new matrix of the same size. Your new elements are going to be -2, +4, okay, +1, -3. That is it, okay? Notice that if you take a matrix and you multiply it by -1, it basically changes the sign of all the elements, okay? That's it. That's what scalar multiplication is, okay? You take the matrix, you take every number inside, and you multiply by that scalar or number out front, okay? So now we're going to move on and talk about the more complicated version of matrix multiplication, where you're actually multiplying two matrices together.